Teraz jest ok? Czy się przestawiały rozdzielczości? Aha, nie sprawdzimy. Dobra, nie będę zgadzał. Dobra. Wchodzić?
Okay, hello everyone, and welcome to 36th Wrocław Meetup. And I think for more or less the first time, or at least the first time for a very long time, I need to say that this meetup is self-sponsored by meetup organizers, so I really warmly invite any companies that want to be visible in Rust community to support us for the next meetups. But anyway, we are for the first time at Barbara in Wrocław, which is a lovely place. We hope to maybe make this our home forever. Who knows? I will be super happy about it. Yes, so we are Rust Wrocław. We are, I think, the oldest Rust community in Poland. At least if you count how many times meetup have happened. And I think what I can do is to tell you to go to rustwrocław.pl and join our Slack if you want to connect with us, because there are quite vibrant discussions on Rust and not only topics. That's what we do. Okay, and now it's a bit strange, but I think I need to introduce myself because I am also the first speaker. So let's do this. My name is Michał Wojcikiewicz. I am a Rust developer. I work at Klikatech. I am organizer of this meetup, as I already said, I guess. And you can see my GitHub and GitLab user handle. I do some small stuff over there, but not that much. You can find me on Mastodon, or preferably on Rust Wrocław Slack. Yes, that's me. And I know this talk is about DFFT, and this is quite an interesting topic, but there is also something very important I think we need to celebrate, and this is release of Rust 1.75, which introduces async function traits. This is a feature entire community waited for forever. And this is great, especially that what also landed is return infiltrating traits. I will not dig that deeply into what this means. If you write Rust, I am pretty sure if you wrote any async code, you have stumbled on these limitations. These are now somewhat gone. There is still some work to do to make it a really nice experience, but this is a huge breakthrough, especially, I mean, for entire community, I think, but this is very important also for the embedded Rust community, because this means that Embassy, which is, I would say, a leading RTOS / async runtime thing in embedded world, is now possible to build using stable Rust. So previously they said that Embassy is guaranteed to compile on the latest stable Rust version, but it was a bit of a stretch because without the several features that require nightly, it is almost unusable. But now they say instead of this, they say, Embassy is guaranteed to compile on stable Rust 175. And this is great because a lot of projects can jumpstart right now, I think also in a commercial space, because who would start a project using nightly Rust, right? In 2024. But what's also released, and it is even more to celebrate, is Embedded HAL 1.0, and this is the first stable release of fundamental crate that provides common APIs for all the microcontroller-like devices. And this is also great because there was a huge split in ecosystem. A lot of crates supported only, for example, Embedded HAL 0.2. Some supported 1.0 release candidates and so on. So it was a big pain to align all the versions and so on. Now, these days are gone or almost gone because let's give some time to maintainers to bump the dependency. But anyway, this is a huge thing for embedded Rust, and I think this should kickstart the whole embedded situation in commercial space. Okay, but now the title of my presentation is DFMT Info! Exclamation mark. I am a microcontroller, and this is very some magic symbols cheap. And this talk is about a logging facility for very performance and memory constrained devices that allows to do quite comprehensive logging without spoiling the application with a lot of overhead just because of logging. So, if I write a better application, no matter if it is Rust or C or whatever, I want logs. I want to print some stuff that is like, helpful to debug some things. But usually it is too expensive to afford printing strings over the debug interface. So what embedded developers usually do is they use a lot of GDB and they do like step debugging and so on, and this is awful because this is not the same experience, or you need to halt the system basically to see anything, and this is bad. And if you ask me, logging is a way better approach. So if it only was cheap enough to use, but as I said, on microcontrollers this is very expensive, and there are a lot of microcontrollers. Some of them are very small, some of them are quite big, so sometimes you can have printed logs, sometimes you cannot afford it, sometimes you only enable it for specific builds, and so on. So today I chose very small microcontroller, STM32L011, plus some these last digits and letters are about the memory size and the enclosure, I believe. Okay, what it has? It has 16 kilobytes of flash, not a lot to work with, and 2 kilobytes of RAM. Neither a lot. But using DFMT, you can have your cake and eat it. So I'm kind of a salesman of DFMT right now, and I can assure you that this little boy can fit entire Pantadeusz inside with some trickery. So Pantadeusz is way bigger than 16 kilobytes if you don't know it. This is, by the way, a famous piece of Polish literature. So yeah. But how it's done? Okay, so I wrote this small program that does this main function, right? We say hello world because why not? And then we print Pantadeusz Księga N. So we print it chapter by chapter. And if you go to if you look how it works, it just prints huge strings. this is like tens of thousands of lines. I assure you this is a lot more than 16 kilobytes. So, how it works? Let's see if it works at all. Yes. So we are flashing our microcontroller that I have plugged to my computer, and it is printing Pantadeusz. It's quite nice. It is close to the end right now, I believe. Yeah, let it finish. Yes, it finished, and now it is idling because it had done its work, and it was a lot of work. How is it even possible that such a tiny microcontroller with tens of megahertz of this small flash was able to print this? Actually, it was not. More or less later. But what we can also notice is that this is idling in a loop, iteration 0, iteration 1, 2, and so on, right? Because we have this format string here. So apparently it is not like just a static string that we have on host, and let's say our microcontroller is commanding our host to print this, because we have these variables here, right? This is not the case. I want to show you some. Yeah. Okay. So this is like we can print. Little spoiler. We can print some logs that depend on runtime state, because let's say it could be possible that it is just incrementing a value, so maybe there is some magic trickery. But let's print the state of pin. I don't know if it's visible on camera. I think it's visible for people who are here in person. There is this very small nuclear board, and this has this single wire, and this wire is connecting one pin to ground. But if I disconnect it, it will change the state. Okay, so let's run this application. So it's log input state. Okay, and now it says pin state is false, right? So if I now disconnect this cable, it says that pin state is true, and now it says it's false again. So apparently this is like a viable log that can give you information about the runtime state of the microcontroller. What we can also do, we can execute on-target tests, because the FFT has on-target executor, and this can be done, if I remember correctly. I should have this somewhere history. Yes, cargo test ---- sleep, and this test, let me show you. What it does is it checks if pin is high, and if it is not, it fails the test, right? So this would happen, and now let's disconnect the cable and do it once more. Now we run test on target, and it passed. So we can run tests on target and use all the hardware peripherals and so on. So this is quite cool. Yes. And now I can show you some trickery I did. This is very low quality, work in progress, POC, whatever you want to call it. And this is a plotter. So what is possible here to do is also for microcontroller, I will let's say generate a triangle signal. Triangle means that over time the value rises linearly, and when it achieves some level, it declines back to, in this case, 0. So it's stepping up to 100 and then down to 0 and so on. And if we if we run this example, what it will do is it will very frequently output a log, right? Like 100 times a second, but it can be even faster. But what we can also do is we can run it with this magic parameter, which is --JSON, and the log will be outputted in JSON format instead, so it will be quite easy to do something useful automatically using computers and not eyeballing, right? But that's not all. What we can do is we can write a very simple application. Oh, I think I missed a slide here. So yeah, the JSON output. This is like an option that you can pass by via a parameter. This is one part of my hacky solution. The second part of my hacky solution is Ratatouille. This is a fork of TUI RS, which is a terminal graphical user interface library. This is like, so TUI RS is no longer maintained, and this is the fork that took the lead, let's say. So it allows you to create very nice terminal interfaces, and this is what I'm using here. This is like, as I said, very hacky solution. I just have some JSON serialization going on. We are taking, okay, so maybe let's look how this is called. So we are just running the program, the JSON parameter, and then we pipe this to my little Ratatouille program. And Ratatouille program collects all this data and draws a plot in terminal. And by the way, very nice feature of Ratatouille is that it can draw plots using Braille alphabet. And this is a very cool feature because it can draw plots using sub-character precision. Because what Braille letter is basically a set of dots, and it just happens that you can draw any combination of these dots. So why not use it for something else than Braille? So let's see how it looks like. Okay, so this is our triangle function plotted in the terminal. I think this is pretty neat. By the way, this is a bit hacky solution. I cannot even leave this program because it does not track to any control sequences. But okay, let's maybe repeat this just for fun. Let's change 10 milliseconds to, I don't know, maybe 2 milliseconds. Yeah, let's build this and run it one more time. Oh, look at this. Oh, what's going on? Okay, maybe.
You have extra comma.
Oh, yes. Okay. It is. I was not aware that you can redraw the terminal screen that fast even, but it's like a very nice operation of very nice terminal interface library and logging facility on microcontroller. So we are plotting this out of this very small, very weak microcontroller. Okay, that was fun. It would be very nice, I think, to create a to write it properly as a built-in feature for ProbeRS. So you could, for example, have your logs on the lower half of your terminal and do some plotting on the upper and whatever. Ratatouille is quite extensive library, so yeah, that's an idea. This is not a declaration from me that I will write it, but who knows. Okay, you can do a lot more things, especially around formatting your logs. You can do you can print some bit fields in a very specific way. You can intern strings. You can do a lot of stuff. But why am I telling this you if I have not told you even a single word on how this works internally? How is it even possible that Mickiewicz fits in such a small microcontroller? Long story short, you should just read the book, because this is a very nice piece of documentation, as it frequently happens in Rust projects. But yeah, maybe let's look at it at its internals a bit. So if you look at maybe something like this, right? You have this idling in loop iteration, and there is this format entry, and what this macro creates is it is putting the string literal from this format macro into a special section of elf file of your compiled program. It creates some custom section and puts this literal into this section instead of putting it to microcontroller, and then creates a lookup table on which number on wire corresponds to which string literal. And then it never lands on microcontroller, but is accessible by debugger, because debugger is using this elf file that contains this section. It is not stripped down, right? Then there is some linker magic. It does some deduplication, whatever. No, honestly, it does not. Linker do not like any duplicates. So if you would write two strings, like if you print twice the string that will be interned and do it exactly this way as I showed here, there would be a linker error because of double declaration. So it's not this way internally, right? So how it's done? Here is the illustration of what would happen, right? So there is dfmt info done, and it creates two symbols of the same name. So it's not good, will not link. So how it's really done is there is information on which crate contains this column. It contains the string literal itself, and it contains some unique number, like in the scope of crate it is unique. And this is what lands into this linker section. Yes. And by the way, and you can see that the symbol here is in both cases 0, but there is this ambiguator. Oh, that's something I didn't notice. Maybe it's a mistake on my side. Never mind. Okay, but this ambiguator is also a feature, because it looks like just an overhead here, right? But what this allows you is to localize where the print was called from, because as you can see here, debug idling in the loop iteration 24, and this was called from hello main function in the file src bin hello in line 20. So this is very nice, because even if you have the same strings all over the project, because you copy paste, lazy bastard, then you still have like a unique source where this comes from. So this is very helpful. Okay, the other thing that you need to do to write dfmt is to move log levels to compile time, because you don't want to even send, even if this is cheap, more on that later, even this is only a couple of bytes, still if you just want to, let's say, observe the regular flow of application, you don't want the, let's say, trace level prints that you can also do there. So it will just get rid of it. As you can see, how I called, project. Okay. If you look at this, there is this environment variable before cargo build, and this is different than in most of different log crates, because usually you pass similar environment variable to the binary itself that you run. But here you need to pass it to your build call. So it will only include the prints to up to a certain log level that you desire in this build. So this way you can mix and match depending on how deeply you want to look into the code, or how close to original performance you want of the application. So that's kind of neat. So how it looks on the wire, because this is, I think, the most interesting part of what's going on here. So if we call dfmt error data and then some formatting instructions, as I said, this is very extensible library if you want to print in a very specific way, which is often helpful in embedded development, where you play with bits and bytes and do some bitwise operation and all that stuff. Then, so this is like data, and this is a type hint that you want, that you will print 3 8-bit variables, and yeah. And what is landing on the wire is the string index, which is like, yeah, this identifier of the string you call, and then the data to put to the slice. And as I think you expect this already, on the host side, it will look up which string this is and will perform formatting on host. What's also done is that there is a custom formatting trait instead of core FMT. There is dfmt format, and there is a single one. There is no like display, debug, and all the other traits. There is only a single trait, and this is because what authors of this library want you to do is to be able to, for example, change the way some variables are displayed in runtime. So, for example, you could switch from hex to decimal and so on. Yeah. Yes. And then there is a timestamping magic. So there is a host side timestamp in the logs, and there is also a target side timestamp. So I will not dig into this too much, but just read the book. Yeah, there is a lot in the book. And there is some stuff about global logger synchronization, because calling logs can be reentrant. For example, because you can implement your own debug format for your type, you could, for example, log inside your your implementation of format trait, and it would be reentrant, even without any preemptiveness and so on. But also you can have preemptiveness and so on. So you need to somehow synchronize all of this. And I think the only thing I would bother to mention here is that I think if you log inside log, it will just be dropped. So only the outer log will be done, and the internal logging will be skipped. I think, at least in how it works in ProPRS, but I didn't play with it that much. Okay, so now we received the log frames on host. So this was one such frame, right? There is, I think there is some header or whatever. Honestly, I don't know, but each call to the dfmt macro will create a single log frame, and what we do is we assume that all the frames are passed without any losses or wrong byte values or whatever, and then we look up format string in our custom elf section. I think is this the latest version of this presentation? It was already close to the end, so maybe it's even better. But anyway, yeah, this basically is like you look up the string in this elf section and the formatting arguments, and then you more or less execute your regular core FMT traits on the string. Literally, you have in section plus the data you received on the wire. And this is how it works, more or less. Please read the book, because this is, for me, when I first heard about the FMT, it was like, what the hell, this is genius. Like, why have I never thought about it? Because this is quite a simple idea, but the execution is very nice, and it changes a way how you can work with microcontrollers a lot, if you ask me, because logging is so much better than step debugging. By the way, what you could also do is, I think, if you do a proper like a version tagging and keep the database of the ELF files and so on, you could even maybe store these logs in the flash if you want to, like persistent logs on the device, and then extract it if there is a necessity for it, and so on. This crate is quite modular. And yeah, that would be quite an interesting idea to have logs that cheap to, let's say, audit the operation of the device and so on. Yeah, thank you very much. I believe it was maybe a bit quicker than I anticipated, but I think this is good because our next speaker, Patrick, is performing a live coding, so I'm pretty sure he would use additional time. But anyway, yes, if are there any questions? We have a second microphone for people who has questions. So
yes. So what I'm wondering is that the microcontroller part is like clean to me, more or less.
Yes.
But what I'm wondering is that how on the host, how does it know how to process those custom format implementations? Like, if I have this trait you mentioned, this custom display,
yes,
the FMT display implemented for my type, how does it know that on the host it has to use this impl that I've got to know on the microcontroller? Or does works differently?
Yes, so the book is honestly quite brief about it. But there are some details on it. I just skipped it because I think I would just tell you to read the book, but we can look a bit into the
RTFM.
Yes, RTFM, but there is this decoder part. No, maybe. Okay, I will pass answering this question.
Fair, yeah.
For now, but yeah. Thank you for the question. There were some more questions, so if you could pass the microphone to.
You said the microcontroller only sends like the number of line to print and formatting data, right? Is it something that is always going to be sent, or only in debug mode? Can this be turned off for like production code?
Yeah, so this will only be sent if there is this DFMT print line, and this one I believe will always be sent if the logger is set up, which you can just I believe you can disable logs at all in like a release build and so on, but in general if your concern is like security of the device?
Maybe not security, but considering that if you add too many logs, it can slow down a little bit the program.
Oh yes.
Then can we like spare these cycles?
Yes. So depending on, as I said, depending on which level of logging you choose during the build, as you can see here, dfmt log equals debug, and then cargo build. Then the binary will be only built with, okay, maybe I have not emphasized this enough, because, yes, so there is this like info, warning, error, debug, and trace. And these are all, let's say, numbered log levels. So if you have dfmt log trace, then all of this will land in the final binary and will be sent over the wire. But if you, for example, only, I think the info is, so the priority is messed up here. But
yeah, it doesn't matter the priority, but it's like
it will be
removed on the binary.
Yes, it will not be on the binary. Yeah, it will not send the string indices below the desired level of log. So
okay, nice.
Yeah,
That was my question.
thank you.
Is there any option to make this formatter to behave, to send direct strings? I mean, I know it's costly, but if you would like to avoid
Yes.
the usage of this pre-processing tool on the host.
Yes. So there is this. Yeah. Okay. Let's just use the book here. What you can pass the strings that are like, let's say, created at runtime and send them, and there is special formatting parameter. As in title of my presentation, if you do it like this, with this equals string, this string will be sent over the wire. As you can see here, this is like the word in bytes. And so yes, you can send strings that are created during runtime inside the but you can, for example, do it this way, that you can only send the variable part as a string that lands on the wire, and the constant part of the string will be spared.
Okay, thank you.
Thanks.
I have a question about more about release of embedded HAL 1.0 than the FMT. What do you think? When do you think Rust ecosystem will be ready enough for production use?
I believe if you, let's say, if you do conscious, let's say, decision tree and consider all the pros and cons and so on, it is already ready for production, because there are a lot of things that are stable, and the things that are not stable, they are not stable in a way that, I don't know, it crashes at runtime or something like this. This is more like you cannot expect the author of the library to not to change API in next 2 months or something like this. So if you actively develop a project and the code base is not huge, but let's say a team of few people, I think that the maintenance cost of ecosystem changes is negligible. If you ask me, as a Rust fanboy, negligible to the benefits that Rust will bring to you in case of memory safety and so on.
To be honest, I was more concerned about bugs and stuff. I mean, only got interested in Rust like a month or two ago, and I made some small project of my own for microcontroller, but I hit quite a few bugs. Known bugs, some bugs in cargo, some bugs in some libraries. One library just exploded my binary size from a couple of kilobytes to a couple hundred of kilobytes. So I've only been I've only used Rust for a month or so. So the question is, are you familiar with this kind of problems? And
Yes.
do you think they will be? What do you think is the timeline for shaking them out? Like 1 year, 2 years, 5 years? I mean, since I came to Rust in 1 month ago or so, I have no idea how fast the ecosystem is moving.
Yes, so I think there is no definite answer.
It
But-
depends.
Your guess would be enough for me.
No, it's not about guessing. It's about which part of the ecosystem. Because, for example, if you want to write something on STM32, I believe you are good to go. This is from my experience also. Oh, by the way, what target you wrote on?
STM32.
Okay. And what was the library that was problematic?
I had quite a few problems, but the library that I mentioned, the one that exploded my code size was, I think it was called SLint. It's a graphical interface library.
Oh, okay, I see. Yeah, so
I think it was connected to how Rust formats strings. Because like DFMT, like you said, does magic to actually cheat
Yes.
formatting out of the microcontroller. But since I've hooked up actual display, it has to be done on the chip.
Of course.
So I think it pulls in quite a bit of this logic.
Yes, so what I would say to you is that if you want to write on ARM microcontrollers, especially for STM32, in general, so if you consider compiler target and like the basic ecosystem, so the Cortex-M runtime crate and embedded HAL and so on, this is in quite mature state. Beside that, one embedded HAL 1.0 was just released, but it was in a way of runtime stability. It was stable since a long time, I believe. But if you ask me about, it's a bit like it would be with Node.js. So when will Node.js be stable enough to be suitable to write backends? It depends on the libraries you will use, right? So the ecosystem is not does not have a uniform quality. So if you use crates that are well maintained and so on, I believe you are already good to go.
Thanks.
But yes, some targets are not stable, and there are improvements. They are quite rapid. For example, ESP32 ecosystem was like almost unusable like a year ago, and right now it is quite nice. So it all depends on the community over a given target and over a set of libraries that you want to use. Yeah, we can have a talk about the graphic library you mentioned after the collection.
Sure.
Yeah, the talks. Yeah, but it depends. Any more questions? Okay. Okay, I guess no more questions. That's good. Thank you a lot. And maybe I'm a bit sorry that my presentation was, as usual, a little bit sketchy. But I hope I at least sparked an inspiration in your hearts. Thank you. And now I believe it is time for a break, but I am not sure if pizza is already there. It is. Okay, so yeah, we will have a break now and we will be back in, I don't know, I think 20-25 minutes. So YouTube watchers see, they don't hear, right?
Przełączyłem YouTube, to myślałem, że już mam przełączyć. Ale słyszeli, że 20 minut. Tak, słyszeli, że 20 minut. Na echo, strasznie na echo czekają. Na echo. Tak. Zresztą możesz zobaczyć. Ja wiem, dlaczego echo może być. To jest ten pierdolony monitoring. Ale nie jestem pewien. Aha, musiałbyś przełączyć. No, teraz musiałbym scenę przełączyć. Dzień dobry, co tam, jak tam?
Fajna prezentacja, ciekawe.
Dziękuję.
Nie wiem, kiedy już widział wcześniej.
Tak?
Nie, gadaliśmy, że na SKS-ach kiedyś
dużo bardziej rozbudowane. Na SKS-ach?
Znaczy to kiedyś chyba, nie wiem, czy to
A może wspomniane było?
Czy przy kawie gadaliśmy też?
Zawsze
Backend do tego DFMT, teraz jeszcze to mieliśmy jakiś UART albo nie wiem, cokolwiek innego, to tam w miarę sposób używania.
DFMT samo w sobie jest backend agnostic.
Panie, jak jest? No to domyślam się, tylko czy tam gdzieś jest jakiś switch do przełączenia backendu, czy to trzeba jakiś
Nie, po prostu ty sobie na targecie możesz zaimplementować jakikolwiek sposób przesyłania danych scenarizowanych przez DFMT. I na hoście sobie możesz napisać w dowolny sposób.
A co jest w tym case'ie? W tym case'ie masz co? Poznaję przez buta, czy jakieś... Co to?
Listem hosting.
Bo ja używałem to, ale to też.
A, muszę chyba z własnej kieszeni. Tak. Nie, bo przez takich jak ty nie mamy. Siostrą przez takich jak ty. Ale jak to oddam? No właśnie widzę jak to oddałeś.
Ale...
że nie masz tam klucza, po prostu większego jedź sobie z tego
Ten, który masz 20, ten 20 zł, drugi 4 dychy. Ten z Ubuntu 4 dychy, ten co pobiegł chyba po pizzę.
Ale nie wiem, może nie macie perswazji, bo ja gadam z mówię, Mika, słuchaj, ale ja mówię te części, a się okaże, że ktoś
Co ty? Łukasz, jak będę uciekał?
Wtedy myślałem sobie, kupiłem rower elektryczny, nie? Kupiłem rower elektryczny, nie? Chciałbym swoje sterowniki tam, wiesz, grać i we flatach zrobić widget. Do telefonu.
Nie to, że nie zamówiłem,
No i teraz pomysł, nie? I teraz właśnie myślałem, że to napisać, ale nie miałem
nie zabierają. Ja dopiero to zamawiałem. W sensie DFMT-u? Nie, to jest bardziej stylizowane o jeżeli chcesz książkę o M12, jest coś takiego jak do Drasty, tak, to jest dobry start. Tak, po prostu tak jak sama, w sensie tak jak gaz, taka dokumentacja. Tak, to się nazywa Leo. Tak. Są jakieś różne wersje? Tak, ogólnie teraz jest tego hardware'u takiego kolorami jest mnóstwo.
sprzęt podpisywany na ludzi, że musisz się z tego dowiedzieć, jak dostaniesz pendrive'a i dostajesz jednego, a jak dostaniesz kolejnego, to jest, po prostu się tam stakują, nie? I później ktoś przyjdzie smutny i zapyta, to dawaj pendrive'a. To działało nawet.
Monitor na klawiaturze jest, ale nie ma na... O, to jest tak, że ja nie chcę się teraz powtarzać, ale nie chcę czegoś, ja wiem, że to jest tak, przeze mnie zaraz nie robiłem, ale nie, raczej się nie powtórzę. Nie, to był akałet, to są na przykład. są, ale chyba jeszcze raz poszło to na biurko, drugi raz poszło może być tam niezmiernie na elektrodzie od 30 lat, one są fajne, to są
Tam zorganizowanie większych
ale to są też
Zawsze możesz sobie zrobić tak jak tą płytkę,
no właśnie.
dodawać na PC pakiet, zrobić kofana. Zresztą koledzy jak naprawiają retro rzeczy, to właśnie bardzo często to tego typu ustrojstwo po prostu nie ma...
Tak.
Jeszcze zastępów przez zalaki się znajdą, ale już nie w gimie.
Cześć, dzięki.
Ono stało drugie, ale dzisiaj...
Musisz się zastanowić, dlaczego ci to pokazuje. No to będą w sensie wyraźnie mi się wydaje, że chociaż powoli leży to jest
Ja bym się nie zgodził. Jak patrzyłem też na SPA jest bieda. Widać, że to się szybko rusza, ale jeżeli się bardzo dzisiejsze.
Pójdzie jest proste. To było na rzutniku przez 5 minut przed prezentacją, póki że nie powiedzieliśmy.
Dobra, ja zrobiłem sobie patrzyłem na Embassy, nie patrzyłem na zwykłe. A Embassy jest tym, przynajmniej z mojego perspektywy ciekawy. Chyba SSM ma dobry support do wszystkiego.
Zgodnie z czasem takiej chwilki szukasz? Wiesz co, bardzo jakieś rozszerzone
to musisz zobaczyć sobie w Daily Sheetie. Następne są bardzo szeroko stosowane, więc jeżeli jest wersja, to założyć na znajomych nie słyszałem, że mieli jakieś wersje na podwyższoną radiację.
Ja tego nie potrzebuję.
Ale na podwyższone temperatury do minus 40 to założyć sobie, że znajdzie. Tak naprawdę nawet jeżeli masz takie do sterowania i tak raczej byliśmy takie
Ostatnio miałem dwa, jeśli nie pomykały, bo ja tak czasami...
Tak, ale na stosunku też konwencyjną, to nie będzie dostrzeżonej temperatury, to i tak to wątpię, żebyś miał prawdę. Bardziej się bym bał na twoim miejscu kit na poziomie tego, że bagaż. Ale możesz jeszcze wiadomo,
to muszę kupować już nie za
albo możesz sobie zamówić z Meetup odmontują. Jak masz w miarę popularny model, to nie mówię, pracuję z kolegą, który jest elektronikiem, nie mam wielkich rzeczy. Znaczy on robi raczej rzeczy takie na 20, 10 osób, miliony. Czasami jest tak, że musi jakieś
website and there will be a link to join us.
Trzeba projektować z myślą o tym, co mają.
Możesz coś na się postawić.
Widziałem, że inny aspekt projektu, nie?
Ja mam strach. Tak, bo chodzi postawił, potem mi się wyłączyło i tego prezentacja wyglądała.
Jest bardzo
Ja troszeczkę się tak bardzo niewiele z apelem bawię. Nie bardzo mogę przyłączyć, bo wtedy się na stronie przyłączy.
Naprawdę do produktów z kolegą używamy
1220 na 1200. Zobaczymy, czy to
będzie
to jest 16 na 9, 16 na 10 potrzebuję. Message me,
Wygląda dobrze, czyli jak to sprawdza. Nie, kolor
nie o tym mówimy teraz. Pod spodem po prostu musiałem ten...
najlepiej widać z perspektywy.
Na moje, ja nie wiem dlaczego ludzie jeszcze się bawią w sensie jak już umiesz i coś też wygląda na świecie.
How we usually do this is we have more or less monthly meetups. A month or 2 months before we look for speakers for meetup, and then we ask for stopping meetups.
Że możesz ustawić mniejszy zegar, ale nie działa. Są też opcje, chyba 10
Yeah, so this would be like a perfect moment when we have like a call for papers, let's say, then to submit the topic of the talk. That would be the way.
Okay, I'll try to, and you speak for like 50 minutes, right?
Yes, more or less like 50 minutes, but with a QA is strange, so maybe shorter, give some opportunity to ask questions. Like 30 to 40 minutes is
Actually, I was asking one of meetings like
yeah, I mean, it's not like I cannot promise you that we will accept your talk, like, but depending on the topic, like,
Nie. To jest pewnie swoja.
Czy nawet więcej. I jeszcze ma nie zdałem, a już jest potrzebny nieznany chodzi o
następkę do tego raczej są takie informacje bardzo ważne. Tutaj to jest bardziej po prostu biblioteka, która pozwala bardzo to służy raczej tylko tutaj. Znaczy, myślę, że można byłoby na przykład w sumie bo ten stan połączył to się dzieje w trakcie tworzy to. Więc żeby tak naprawdę zrzucić stan trzeba byłoby go zatrzymać. Dlatego się używa wtedy sprzętu wymagających. W trakcie go zatrzymać.
Nie tyle, że SM posiadają cała elektronika posiadała, bo radio była pod jakąś tam radiacją. Do tego jest tak naprawdę dobre, szczególnie że zostały radzieckie. Jest można, albo potrzebujesz takie naprawdę dedykowane, że to jest ciekawe, koniec końców rozwiązanie jest takie, że po prostu bardzo stosujemy. To się opłaca, tak? Koszty jakiegoś mocnego myślę, że
nie wiem, już jest chyba powoli się zaczynają pojawiać te kontrolery, które mają feriale, które są jakieś low powerowymi, prostymi akceleratorami. Ale nie wiem, na ile mają
do czego?
do ML.
Wiem z aplikacyjnymi SOC robią, ale na mikroprocki to nie.
Wydaje mi się, że tak jeszcze się powoli gdzieś tam pojawiają.
To raczej do aplikacyjnego, to na mikrokontroler trochę ciężko. Ale chociaż kendryty były z Disk 5. Były, tylko nigdy nie widziałem. Też kwestia tego, że jak się bierze coś takiego, to wie jaki tam jest tak naprawdę support. Najlepiej znać chiński, a i tak trzeba mieć znajomości.
Ale kojarzę takie demonstracje, gdzie ktoś miał już jakby wyćwiczoną całą tę sieć i tak dalej i to się dało skompilować po prostu już działającą sieć do C. i sobie to po prostu wgrać, tylko to będzie wolno liczyć na jeden kod zero.
Pytanie, jeżeli nie masz bardzo mocnych wymagań na energooszczędność, to dlaczego nie weźmiesz sobie jakiegoś SOC z od razu kolem aplikacyjnym? Jeżeli potrzebujesz jakieś time'owe, to te cory, to te SOC mają zazwyczaj jeszcze budowany jakiś mały core, czy to armowy, czy w dzisiejszych czasach coraz częściej RISC-V-owy. No nie wiem, na przykład LK3399 ma 2 M0 dodatkowo. Jeden jest używany do...
jest super.
Tak, to jeszcze obsługa nie jest taka. Tak, ale
pracowałem w projekcie
9.9 są 2 tory, jeden jest używany do trenowania pamięci, więc nie możesz...
O, zmieniliśmy na sekundę. Aha, że to tu już... Umawialiśmy się na to, że zaczynamy tak 10 po. Więc ja bym sobie wziął szybko kawałek pizzy i wracam tu, tak rzuciłbyś tylko okiem na sprzęt.
Nagiewnymi się kompletnie nie znać, pewnie słyszałeś, dopiero się nie zainteresowałem. Wątpię, że bym ci był w stanie wiele odpowiedzieć. Nie wiem, ja kompletnie się nie znam na gameplay, w sensie moje zainteresowanie grami się skończyło lata temu i zainteresowałem się systemami, grzebami w kernelu, systemami. Ja wiem, że game dev mocno się różni, obejrzałem większą projekcję, w których opowiadali o problemach, ale to jest mocno inne programowanie niż programowanie w sterowniku. To jest dobre miejsce, żeby zrobić. I myślę, że nie wyłącznie rzeczywiście za tego trasa, dlatego że ja piszę w tej chwili, to już jak pierwsze, jak już coś robię komercyjnego, to robię na systemach i robię to w celu. Ale to jest dlatego, że jeszcze ja nie uważam, że teraz na dzień dzisiejszy jeszcze gotowy do takich regularnych projektów embedowych. Znaczy, nie możesz go brać w ciemno, jest za młody. Może ci wyjść bug, który jest, no nie wiem, ja naciąłem się jakieś bugi w kartę, tak? Dało się to obejść, ale to nie jest coś, z czym bym chciał pracować zawodowo na dzień dzisiejszy. Natomiast za to masz ekosystem, masz możliwości takie jak właśnie DFLT, dlatego że masz ekosystem, który jest jedny, a nie tak jak w C++, gdzie jest po prostu jeden wielki kurdel, każdy ma inny build system, każdy ma coś tam, więc nie ma hala, tylko jest hala producentów, hale są dramatycznie słabe, więc jeżeli dopiero wchodzisz w to, ja podejrzewam, że za 2 lata z pewnością 50% wydaje mi się, że za 2 lata już raz będzie naprawdę dobre do pisania na większość platform. Tak? Nie tak, że całkiem ciemno to wolna platforma, ale na przykład jakieś teksty są dobrze sportowane, 130, nie będziesz robił naprawdę jakichś mega big klasów, to po prostu raz będzie dobrania bez głębszej analizy, a za 3 lata myślę, że prawdopodobieństwo jest jakieś 75%, bo ja nie znam nas dobrze, więc też nie miałem okazji dostatecznie dużo czasu ogarnąć, widzieć jak się to zmienia, jak będzie tak naprawdę ta zmiana.
Chyba nawet jakaś finansowa. Jesteśmy gotowi? Jesteś gotowy? Nie. Czy jesteś gotowy na 30? 21 Gdzie ja zgubiłem swoją wodę? A, może być. A, bo tam jest twoja woda. Ale to... Smacznego. Nasza woda. Dobra. A to tam też jest twoja. A,
Zastanawiam się nad jedną rzeczą. Jeśli w scenie, której nie używamy, było ustawione 16:10, potem się zmieniło na 16:9 i znowu na 16:10, to OBS będzie to miał równo, czy będzie przesunięte?
Bardzo ciekawe pytanie. Zaraz to sprawdzimy.
Testowanie na produkcji zawsze w cenie.
A dokąd chcesz, żeby sięgał? Teraz cię łapię. Teraz nie. A chcesz, żeby cię łapał?
No.
Wiesz co? Wolałbym nie, ale jeżeli bardzo ci zależy, to może być tak.
Nie, w sensie, no nie, zależy.
W sensie, bo chodzi o to, że musiałbym pokazać praktycznie cały ekran, a ta ramka z kamerką jest mała dosyć. I to się potem tak zrobi, że będziesz 5 pikselami w 5 pikselach. W sensie, nie, to byłoby dużo akurat. Będziesz 1 pikselem w 5 pikselach.
Nie ma co sprawić.
Aha, czekaj, ja miałem tu wyklikać jeszcze jedną rzecz. Mam nadzieję... A, monitor off.
Już nie
Aha.
wyklikałeś?
Nie, bo nie zmieniałem sceny. Monitor and output. Okej.
Live coding. Troszeczkę GPU, na głównym GPU. Mam nadzieję, że uda mi się.
Powodzenia.
Dziękuję.
Bo...
Ostatnio może widziałeś taką dagę, bo w sumie na końcu byłem. No to właśnie. Mam nadzieję, że
Powtórka.
Aha, to samo będzie, tak? Nie, jest trochę zmian. Jest troszeczkę więcej materiału, troszeczkę ciekawiej, mam nadzieję. No i
Da się ciekawiej niż było ostatnio?
da się. Mam nadzieję, nie wiem, próba 2.0. Że przynajmniej uda mi się tak będzie zapisać to i żeby było całym razem, a nie otargane tkanina.
Przedstawisz? Jesteś gotowy, czy ja mam wchodzić na stronę i cię zapowiadać? Ja się sam zapowiadam, bo nie
Znaczy ja zacznę po prostu od monologu, także
Dobra.
przedstawia się tak w minutach.
Dobra, to co, zaczynamy? Tak.
Działa. Okay, I guess it's time to finish our break and listen our second speaker. This will be a great talk, I tell you.
Zaczynamy.
1, 2, 3, does it work?
Tak. To działa, tylko nie mamy obrazu twojego. Aha, dobra. To już wiesz.
Language is weird and fascinating and weird. For instance, you certainly heard phrases like King Kong or zigzag or I don't know, click clock. And you might have noticed that if you swap the order in those pairs, so like zigzag or tactic, it just doesn't work anymore. It sounds funny. And would you know? And this phenomena is called a blood bridge application. So this is the phenomena that, for instance, in English, when you have those onomatopoeias such as TikTok, usually the vowels inside of them follow the I-A-O pattern, as in tic-tac-toe. And if you not follow it, it will sound funny. And you know what else is weird and fascinating and funny? Computers, I think. For the past 2 years, I've been doing some game dev. So implementing games with friends and stuff, or like GitHub's Game Off, and I became very interested in how how computers work, how to write efficient code for them, especially since when you have games, they have to be like real time and whatnot. And what fascinates me the most nowadays is that in computers we have two main types of processing objects, let's say processing compute units. We have CPUs, obviously, and GPUs. And the idea behind CPU, before that, nowadays CPUs are multi-threaded or multi-core. And what it means is that inside this single CPU you have like sub-processors that work together to form this whole, CPU block. And the core idea behind CPUs is that those blocks can do different things at the same time. So we can imagine with, a pinch of salt that one of the cores is like running Firefox, the different one is like crunching some Excel numbers, and the third one is, let's say, storing stuff to your hard drive. In comparison to those, 4 or 8 cores, which are typical for CPUs, in comparison, GPUs have 16,000 threads. So that's way, way more. And you'd be right to ask, what's going on in here? Why you can have GPUs with 16,000 cores, while CPUs are like 4, 8, 32, maybe if you're rich. And the core idea is that if we have some algorithm, such as this one, which does something, then on CPU, it's magic. And then on CPU, if you launched it on separate cores, all of them would be executing, let's say, different lines of this algorithm. But again, simplifying a bit, when you have GPU, the whole GPU, simplifying a bit, the whole GPU launches the same line of code with different values. So each of those 16,000 cores will have different values for the X, Y, and Z variables, but they execute the same piece of code. And at first, this might sound like a very limiting, very stupid thing to do, because what would be the use case? And as it turns out, computer graphics is a very good use case, because you have all of those pixels.
Call of Duty?
Battlefield, I think, but you have all of those pixels, and you need to calculate, you need to perform some calculations to have this graphic in front of you. And for instance, one type of common calculation that you'll need to do to end up with a frame like that is related to shadows. So you will have some place in memory that tells you, for a given light, how far this light reaches into the scene. And then with this information, for each pixel on the screen, you check if this pixel is visible to this light. So you do the same operation, but for different data, for different world positions. And there are tons of stuff that GPUs do for to make this frame. We have motion blur in here, which is also a similar type of algorithm. So you need to blur some pixels to show how fast camera is moving, and you do the same algorithm but with different data. And maybe blue, which I now see is not visible that much in here, but if there's a very bright source, light source, it illuminates sort of the neighborhood to show you that it's very bright in that area. And what I'm going to do today is that we'll be doing some light coding. I'll show you how we can program GPUs in Rust. And that's basically it. I'm aiming for sort of Bob Ross vibes here, and there will be a lot of material on the way, I think, but rather than stressing you out with how much this might be, I want you to rather just sit, enjoy the show. It's I don't think it's rememberable for just one watch, so just take it easy. And before we start, my name is Patrick Habaniec. That's my website. I do have some Rust tutorials and whatnot, a lot of genetic algorithms and what you would not like. You will also find contact stuff in there. And the project we'll be doing today is already on GitHub at this repository. If you git clone it, you can just run it on Windows, Linux, and Macs, and it will just work.
Sorry.
Yeah, no worries. I'll also show this link later. So, yep, right. Let me mount the microphone. Three, one, yeah, back online. So let me actually show you what we will be coding today. Right. Size, I think it's all.
Solaris.
Yeah. Yes, it's Solaris, yeah. So this is what we will be coding today. I hope the window size is all right. Do you see it? All right, maybe you can turn the lights off if it's wrong. I'm not sure. Cool. Yes, so this is our goal, and this is the place that we start with. So we have this triangle. All right, so first of all, this Rust code that I have is two modules, so to say. The first one is what actually creates this window and manages it. And this is like the boring part, which I will not show. It's like 100 lines of Rust code that you can browse it later. It's boring. And the interesting part is what's known as a shader, what you see in here. This is the code that is executed on the GPU. Now, it's a bit different from the typical Rust code, and we'll go through the differences so that it's clear. So first of all, to give a quick brief, what the difference is. This line says that since we're aiming for GPUs, and the architecture is called SPIR-V, we're aiming for GPUs, we do not have access to the standard libraries. So on GPU, we do not have file system, we cannot print stuff naturally, because it's GPU, so it's like a separate machine. Then we have a bunch of imports, which will come useful later. And now the structure, the file, is that we have two main functions. First one is called vertex shader, and vertex shader is responsible for generating triangles, because usually on GPUs all objects are triangle based. So if I were inside a game, my skin would be like 100,000 little tiny triangles forming together. And the second function here is called fragment shader. Fragment shader is responsible for generating the actual color of a given part, a given pixel. And like I said, usually what GPUs do, or what you would do as a game dev, is that you would generate some sort of shape from those triangles, and then color it inside the fragment shader. But what we will do today instead is that we'll generate one huge triangle so that it covers the entire screen, and then you just play with the colors inside, which hopefully will come. Will be visible more later. So first of all, what do we also see in here? So as the input, this function takes the vertex ID, which goes from 0, 1 to 3, 0, 1, 2, and generates this triangle. So this piece of code determines the location of this little vertex. So if I move it to 0, 0, it will go down. And similarly, this one is like the vertex on the right side, mine is your left. So if I move it like that, it will should go to, this does the y coordinates, so this will go up and down, and this will move it to center. And the fourth coordinate is not used in here because it's just, it's used for something called perspective projection, which we do not need to worry about. And then we have the fragment shader, which generates the color. And first of all, you might see that the terminology is a bit overloaded here. So we have this vec4. It's a simple structure that contains 4 values. Those 4 values can represent position, in which case we have x, y, z, so 3D position. It can also represent colors, in which case you might have green, red, green, blue, and maybe transparency, depending on the context. And the vec4 in here is like for position, while the vec4 in here is for color. So this is like red, green, blue, and this one is transparency, but we don't use transparency in here, so this would change it to yellow, I guess, and then doing this makes it white. Alright, so first things first, as I said, we won't be doing triangle magic in here. We will enlarge this triangle, which we can do by just extending the corners like that, not like that. Wonder what I messed up. 1, 2. Free. Man, triangle is acting out. Right, so when I have this one, I'll just move it to... Alright, good enough. Right, so now that we have this whole triangle covered, which is probably like, extends right into here, and probably like that, but for our purposes, it's now rectangle. We can play with the color. So first useful thing to do is that we can take the pixel position and use this pixel position to affect the color. So if this was normal rest function, we'd probably do something like that. Position, then we'd do vec2, which compares to vec4, contains just the x, y coordinate, and then we do some magic in here. But because we're on GPU, this is actually vec4, where we are not interested in the last two places, and we need to tell to the compiler what this variable should contain. Because on its own, the compiler is not interested in the variable name. We need to add this special annotation, which in this case will be fragment coordinate. I think thanks to this, the compiler will put the xy in this position. Right, so we have the position, and this position is in pixel coordinates, so I know for a fact that this window is 0 to 1,000, 1,500 pixels, I think. So I need to divide it so that, for convenience, the position will go from 0 to just 1 as a float. And then hopefully this will give us some shader that actually starts to do something useful, which is this sort of nice gradient. And the convention for this is UV. So as a trivia, UV goes from 0 to 1. And what we can do now is, for instance, do some conditional logic. So let's say if we wanted to draw a circle, then by definition a circle is like a collection of points within a certain radius of the center. And we can code it directly in here. So if the UV length is less than 0.1, then we want the color. And if it's outside, we want it to be pitch black. Now we have a perfect circle, which we can also move around. This should move it to the center. UV, right, so this window is probably smaller, right, because I have different, I have smaller screen for the projector. I know it sort of looks like 750, so let's start with that and we'll see. Right, seems like yes. Right, so we have it at the center, and now what's the step in here to the third dimension? First of all, let's maybe extract this computation to a separate function. So we have circle, it takes some point, some radius, and normally we would also return, we do something like that, so also return like 0, 1 value if it's inside or outside. But as you will see in a moment, a more useful information is actually how far away are we from the circle. So if we do something like that, no, we don't check it in here, we do 0, 1. Now instead of this Boolean information, we have that. Yeah, right. we have this information how far we are, so we know that we are inside or outside. And the route to third dimension is actually not that far from here. So in the third dimension, we have obviously a sphere, which is defined as a 3D set of points that's certain radius from the center. And now the overall algorithm that I'm going to show is called signed distance functions. And the core concept behind this is that if we have a function that tells us how far away we are from some object, and then given some camera position and camera direction to which we are looking at, we can use this information to sort of step through the world and get closer to the object. So to put it in code, if we have some function that defines the whole scene, this would be seen that consists of a sphere that's located at the 0, 0, 0, so at the center of the coordinate space, and the sphere has a radius of 1, so it's like, the scale is arbitrary, but let's say 1. And now what we need to go from the second to the third dimension is the definition of a camera. So let me try to... Alright, so a camera is defined by, six variables if you think about it. So we have the camera position, so if, or the eye position if you'd like. So we have the place where I have my head, and the place to which my head is like tilted towards. And you could also forget that you also kind of like rotate your head, but for our purposes, let's say it does not matter. So this also needs to have the place in the code. So we will need to have some origin. Alright. And if we have a sphere in here at the 0, 0, 0, then our origin cannot be at the same place as the sphere because we will not see it. So let's say that our origin will be at point 2, 2, 2, which is like 2 away, and then 2 away, and then 2 up. This would be vector 3 to 2. It can be obviously arbitrary. And then the direction is a bit more difficult one, because we might imagine that our screen is like this sheet of paper. So the sphere is here, our camera is like here, and then what we need to compute as the direction is here, is that for each of those pixels, we need to find the direction that looks at the sphere, so that we have the perspective applied. This is not terribly difficult, but it involves some matrices that I think would be awkward or long to present here. So I just created a simple helper for that, which I will show in a moment. It was called it's command direction. It takes the origin and the pixel position to show that it is not terribly difficult. So it takes the origin of the camera, the 0 to 1 place of this sheet of paper, so to say, and returns for given pixel, so for given UV coordinate, the direction towards the center. Alright, so now the missing piece of information is the actual point, 3D point, that we would hit if we were to, be this camera. The algorithm to determine that is called ray matching. It takes the origin, the direction, it returns the 3D coordinate of the object that we've hit. So naturally, we, by definition, or like the default state is that we hit nothing, which we will encode as hitting an point infinitely far away. Which on its own is obviously not useful because this doesn't do anything. So now the core concept is that, maybe now microphone will be more handy. Alright, So the core concept is that we have this function, scene, which defines, given a point, the closest object from the point. So if you know this whole scene was this scene in here, then for the point in here, let's say, this function will return the distance to, I guess this would be like the closest object. If we were to execute this scene function for like a point in here, it would probably, I guess, return the distance to the down. And the useful concept about that is that what basically this function tells us is the safe step we can take at which we can check if there's an object there. So if I go in here and I was, looking at this one, let's say it's 1 meter away, this function will return, 1 meter. Right, I ran out of the scene, yeah. So then I do this 1 meter step, I recheck this scene function. If it tells me that I'm very, very close, then I say good enough, this is the point that I've hit. But you might have noticed that this function doesn't take the direction into account. So if I was standing in here and I wanted to check, which closest point I hit in that direction, this function still returns 1 meter before me. But I take one step in front, I still hit nothing. Then this function will tell us to check in 2 meters. Then I check 2 meters away, and I will come back. And finally, the function at one place starts returning, I guess, like this chest and stuff. And then I will be getting closer to my, place in the world. So it's like conservative estimate, if you would name it like that. But it's simple because it doesn't take the right directionality into account. And it's probably simpler in code actually than explained, so let's code it quickly. Right, so the missing information here is distance, because we have origin and direction, so the only information missing is how far away from, given the direction. We will take some loop. The point we're checking is located at the origin, plus some location away from the direction. We check how close we are to anything in the world at this position. If we're close enough, then we've hit something, so let's return that. If not, then we take this step in front of us and check again later. And you might see that this is basically in some sense an infinite loop, so let's also count the number of steps we've taken. And if we've done too many, or we've went too far ahead, both arbitrarily, we just say we give up, there's probably nothing there, the function is acting out, whatever. Okay, so we have this is called array matching, we have this written, and we can plug it in here. If match, it takes the origin and direction, and now this function returns either infinity, which means background, or some finite point. So the condition here switches to if point is finite, then we've hit something. And the spherical ledger, isn't that exciting? No, I don't think so. So now it's time to introduce the first proper 3D concept that will make this actually look like 3D. It's called normals. So normal is like the orientation of given surface. So it's like a direction vector that tells us which direction surface is facing. So if this was my hand, then the normal of it would be pointing when one front side would be pointing upwards. And as I rotate my hand, the direction vector also changes. So then direction vector for this part would be pointing to the left, the right, in front of me. And basically almost everything has some normal vector. This is the place where our code died, the projector went out, so I'm pretty happy that we're still online and alive.
And the question is, given this function, how do we extract the direction of the sphere at this point? Because we have a sphere which is approximated, if we approximate pi to 1, this is sphere, and then it has different normals all around it, pointing to all of the directions. And this is probably like the most mathy part of this talk, because we need to actually properly need to take the derivative of this function, but we cannot. I mean, for the sphere we could, but in general we cannot. And I have some extra slides to show what I mean. Okay, 1 minute add-on derivatives. If somebody doesn't know, when we have a function, we can take its derivative, which is, if we are given a point, the derivative is like this tangent, well, let's say line to the point. And we can take derivatives, obviously, analytically. So if we have some function, we can sometimes compute the precise derivative. But in general, if we had, I don't know, let's say cube, whatever, some random shapes in the scene, we would not be able to derive this analytically. So what we can do instead is that we look at the neighborhood of our point, very small neighborhood, so like minus 0, 0, 0, 1, plus 0, 0, 0, 1. And if we take the difference, this sort of approximates, very close difference, this sort of approximates this tangent line. And approximation is good enough because computer graphics is mostly smoke and mirrors, so. Alright, so what we need to write is that this normal function takes world position, it returns some direction vector. As I said, we need to take small steps around the point we're given, so something like this should do it. And we have 3 dimensions to check, so we have to check the x coordinate, the y coordinate, and z coordinate. Oops. D. So there's like small steps around those 3 axes. And now what this g stands is like a gradient, so the gradient is like this difference between those 2 points, is that we look at the scene at point plus, point minus. We do this for all points in here, so alright, so this just approximates this, derivation. For our purposes, what it returns us is, as you will see, this sort of rotation at given point. And it needs, let me just quickly reiterate how neat it is that we have 3D coordinates that use x, y, z, and the colors also are like 3 components already we didn't lose, so this means that we can just visualize this 3D direction with just basically colors. And voila! It sort of starts to look like 3D. We can try to move the camera. So this coordinate was the height, so like the y coordinate up and down. If we move it to 0, 0, we're moving down. Then minus 2 is like from the bottom. And then we can move far away, far away. Alright, so rotation is neat, but what we can do with this? We can do lighting. Yes, I always mix lighting and lightning, so no, lighting. And for that, we just need one simple concept. It's called dot product. But for our practical purposes, what dot product is like given 2 directions, dot product is similarity factor of them. So if we have 2 directions like that, dot product of them is 1. Then as they sort of diverge, the dot product goes to 0, and then becomes negative. And this exactly corresponds to how lighting works. So if we have a flat surface, then as I move, let's say that this is the surface, this is the light source. If the light source is perfectly on top of the surface, it gets 100% of the light. Then as the light is like getting down and down and down, and this angle between them changes, the surface becomes darker and darker. So let's say that we have this similarity factor, and that let's say that our light is just, the sky, so it's on the top of us. And so now, instead of this, we can try to do, back 4, so this would be the white color, pure white color. If we multiply it by the similarity factor, we start to get some shading. And let me quickly change that to actual nice color. I think crimson, it went like that. Yeah, okay. Now, as we as we move the light, but for that we need one more thing. For more math-oriented people, the similarity factor is actually the cosine of the angle, so we can name it like that, because if cosine of 0 is 1, then cosine of, I guess, like pi is 0, and then it goes negative. Decant, similarity factor. And one key point we need before moving forward is that currently, for each point, we check if the light is, above it. So if we would imagine very, long surface and light, like a point light in here, then for each point on the sphere, it's not like the light is, above all of the points. It's like in one point, so the angle is different. So this, cosine should be different for each point. So what we actually need to do is take a look, place the light somewhere in this scene. So let's say it's, like that. And then we have to compute this angle between the surface we've hit and the point. Minus point. And this will come a bit important later. And one more cool lighting thing we can do is that we have this one type of lighting which is called diffuse lighting. It's like the base color of an object, so to say. But this is not the only kind of lighting that we could have. So we have this diffuse lighting, which is this one, times the cosine. But there's also a thing called specular highlight. So if you imagine like a metal object, and then if you have a light that shines at the right angle, you see like the light reflecting more, at certain angles of this metal surface. This is called specular highlight, and you can approximate it in here, because it looks very, very nice. So instead of taking just the cosine, we'll take it to some power. And how this looks like is that we add both of them. We add the W coordinate, which we don't use anyway, but need to satisfy. And voila, this is, nice, simple touch, but it adds much more to the readability of the scene. Now this is, I think spheres I need, obviously. Hexagons are better, but I know we can fight with that. But one cool thing you can do with this sine to distance function is that you can basically play with them to see what comes out of this equation, because now everyone knows how a sphere looks like. I hope you've all seen some boxes in your life, or maybe triangles. But like, what would happen if we would, instead of hard coding, just radius to 1, what would happen if we would like do some multiplication that is basically, hard to imagine. So what this
maybe cosinus.
I have an example of sine, which we can then check if it works with cosine, because now this makes me curious. But let's start with sine. So I do not really have an intuitive explanation for what this does. So for spheres is easy to understand. This one is just like something you might randomly stumble upon, and this is part of what I would like to show. You have this algorithm that you can essentially play with and see what comes out of it. And for this, we need to actually move the camera a bit further, like that. We can make the sphere a bit bigger, and let's do some, it's basically random stuff that you can do. Let's say that I do this. And Yes, total, no, this should be minus, yeah. All right, and we need to move the light a bit, so let's move the light at our position as well. All right, so we have triangle-ish with like dent inside of it. And what we can do is that first, if we extract this,
It's a bike saddle.
it's what?
Bike saddle.
It's bike seat, right?
Yeah.
Yeah. What we can do is we can sort of animate it. So we might notice that if we multiply those by, some what's the word I'm looking for? Disfiguration factor, let's call it. Then disfiguration of 0.0, which will bring us the sphere again. So let me save it. Disfiguration of 1 will make this bike seat. And what we can do to animate it is that we can pass the time from the application and change this disfiguration factor with time. And I think the output will be very nice, but we need to first pass the time in here. So let's assume that we have time. Or maybe no, let's start from the top. So we have this input, so the main function of our shader. It takes the position which we already added at the start, and now how we can pass time. And this looks sort of more magic because you cannot just pass values from the application Rust that calls this function. It doesn't call it directly. You sort of instruct the GPU driver to do it. So passing stuff requires some trickery. Basically, you have to have a struct, which I've already declared in different functions. Since this is actual, then we provide the width and height, which I've hard-coded to 750 in there. It also passes the time. And this is what you would do if this was normal code, but because this is GPU driver, we need to pass some extra metadata so that the compiler and GPU knows what they are doing. It's called descriptor set and binding, the type of the binding. And what this means basically is that this is sort of like the index, because if you have multiple params, you can index them with this descriptor sets and bindings, and you just sort of map it on the application side. In this case, it's just like the first and the first. And then this is the type of the binding, which there's like different one for arrays and different one for structs, but for our purpose, it's just like simple struct. The struct has time in it. And yes, we need this to pass this time up to this scene. So this requires a few modifications because first of all, we call this scene in the array matcher. Right, so we have time. And also the normal function also now depends on the time because it also invokes this scene function. So like that. And oh yeah, that's true, missed this one. Alright, the code compiles, so now what we can do, we could pass the time directly, but since we know that this factor, I know that this factor only works in cases between -1 and 1, and the time already went to like 30 minutes on this time factor, then what we can do is just take the sign of it, so that it's like this wave. Now, it deforms badly, in my opinion, for the negative values, so let's take the absolute value. Now we can speed it up a bit. Now if you do one final touch and square it, you'll have this sort of kick to it. And I don't know, this is not terribly difficult, it feels random, and like I said, there is no, I have not managed to prepare an intuition, but what I like about it is that you can basically play with it to see what comes out of it. We can see what does cosine doing here, but I think this will be the same animation. Yeah, sort of changed. We can do all, I don't know, like tangent, whatever.
Oh, that's nice.
Yeah. And for comparison, if you would like to do that with typical graphics and do like GPU with triangles and stuff, this would be terribly difficult. But in this, it's like, whoops, this like defines our whole scene. And yep, so what comes next is that we will do this ocean animation. And yep, wondering if I have not missed anything, but I think not. So I will introduce one more concept related to signed distance function, which is how to, sort of join them together. Because you might think that having one sphere is nice, but I'm rich, I would like to have 2 spheres, or you're very rich, you want to have 4 spheres. Oh my god! And it's actually easy. So just to quickly do, if we have one sphere in here, which will move around a bit, so like, I don't know, to the side, and needs to be smaller probably. Then we have second sphere, which will be mirrored. Then if we pass the distance to the first, we'll get the first, distance to the second, we'll get the second. And intuitively you might think that we should pass maybe the sum of the distances, but then it doesn't work. And what we actually need to do is that take the minimum distance out of them, because as we cited, this scene function should always return the minimum distance to the closest object. And then the spray matching algorithm, it will find this hit point, but it needs to, for the scene to be reasonably behaved. So if we take the minimum, it will actually find both spheres. And for the ocean, we'll actually do something a bit different. So let's first start with the ocean. It's also signed distance function. Let's start with just a flat plane. Yeah, I'll leave the sphere in here. So this will print just a flat plane. That's because this will sort of nudge the ray matching algorithm to find the surface below it. If we change this to x, we have a wall. If I only don't make the mistake in here, this gets us sort of the wall. And now if you... No, wait, let's start with the color. I almost forgot about the color. This should be blue, which should be something like that, I guess. Good enough. Yes, so we have the ocean. And the object we had at the beginning was like oceany sphere. So we have sphere in here. Make it bigger. We have ocean in here. And we know that if we take the minimum, it creates this sort of, well, it joins 2 shapes together. And in here it failed to find the solution. The plane is there, but we probably hit the 64 steps limit, so this is just a quirk. It will disappear in a moment. So minimum finds the union of 2 shapes, and to find the common area, we should do maximum, which returns the common area between what I've mistakenly named plane. This is actually like a box that spans from the 0 up to infinity below. Because if this was just a plane, then this part wouldn't be visible, but it's a box. We'll make it a bit bigger, maybe like that. Alright, and we can affect the height of each pixel or each word place by modifying the distance returned in here. So like that. The general form is like this. So h, which stands for height. If height is 0, we have basic. Height 1 brings it to the top, height negative to the bottom. And we've made a lot of signs in here. So and the sign looks sort of like an ocean. So if we again take the sine wave, we will get sort of the ocean's vibes. The second sine wave to get the 2D ocean. And yes, I will be coming to an end, but not with the simulation yet. What I wanted to say is that now I'm sort of stopping to explain. This is the last part when I will just write this about 20-line algorithm. And I'm mentioning it because, how to phrase it? I can phrase it. I can put it in directly. I was not able to find accurate explanation that would fit in 10 minutes. So I want you to just sort of chill out if you have not, see how the code plays out. It's not terribly difficult, and as I said, the repository with more comments is also at my GitHub, which I'll show later. And yes, let's do some ocean coding. Oh, I can do some high-level explanation of what's going on. This is like one level of sine waves, and what the code will do is that we will take 16 different sine waves, randomly shifted, and sort of join them together. And as you will later see, it actually creates a nice oceany like simulation. All right.
Maybe we can play some music.
Skibidi toilet, yeah. I'm not sure. I could have prepared a music, yeah. So we have frequency.
We're playing what's H_B usable does.
So this, well, if there are questions, I can actually try to explain. So this will be a weighted sum. So this will be like the sum of the values and then sum of the weights. And this is just like a weighted sum of the waves. This just generates some noise, and sine and cosine happens to align with what we need. Then, yep. Right, 3 more to go. So we need to multiply the frequency.
And I wonder where we change the value of noise, because it seems at the beginning, okay, got it.
Okay, yes. Now let's try it. See if it doesn't blow up in my face. Oh, maybe I've made a mistake. Maybe I have not saved. Okay. There's a variable with the same name, t. Right, I have not passed time in here, right. And it's animation, so I should have time. Voila! We have ocean. There are a few more things we can add to the simulation, like, we can make it faster if we multiply the time, so like...
Can we make it greasy brownish, just like Odra River?
If you know some RGB color for brown, we can. I know for green because 0010.
Okay.
No, this is more blue, which is not correct. Yes, this is my spawn. Yeah. Alright, you can also move the light a bit further to see that this highlight is still there. And yes, I guess thank you. Just before we finish, I do have one more topic to like due diligence to say. So one of the questions I've gotten on Code Live is that whether you can use Rust to write like shaders that operate on data, not only on graphics, which is you can use computer shaders as is known. And also I should say that if you're like learning Rust, then probably starting with shaders is not the greatest thing you can do, because this is not like what I'm showing here looks like typical Rust, but like there are some quirks, especially with graphics, that can be difficult to wrap one's mind around if you are both learning Rust and graphics at the same time. I would encourage you to play with it. I'll show the repository once again if you'd like to check it out. Like I said, it should work on basically every system, maybe except FreeBSD. Sorry for that. And yeah, thank you.
I guess also, do we have questions? Because I think this would be important, yeah.
Questions. I want to ask first myself because then I will lose the microphone. Why this is so weakly typed? I mean, you only have like VEC4, VEC3, and this only the only type information here is the length of this vector. Wouldn't it be better to have like dedicated color and space types or whatever?
Yes, and there are libraries which allow you to do that. I forgot the name, but I was reading about one even recently, so maybe posted on the Rust GPU project somewhere. There are, but it's like still sort of bare bones. So another due diligence part I should mention is that this does not use LLVM, so this is Rust, but it doesn't go from LLVM, so it doesn't have all of the optimizations typical Rust code would have. Instead, it's like crane lift. It's not crane lift, it's like crane lift, so it's like dedicated backend to generating code. So it doesn't do all of the optimizations. And for instance, it optimizes for loops and while loops differently, and while loops are faster than for loops, so it has some quirks like that. It has sometimes miscompilations, so you end up with wrong shader. You've written something correctly, but it doesn't work, not because you did something wrong, but because the compiler is like sorting itself out. So there are still some rough edges. And one of these rough edges is, I guess, like this weak typing, as you mentioned.
Right, so I'm interested in what rendering API you use, because you only showed the GPU part with shaders, but you didn't show any of the backend.
Yeah, I was actually thinking whether to show the backend side. It's WGPU, so it uses bare bones. I'll close this one because it hogs the GPU and cannot scroll. Uses Winit and WGPU, so this is just basic window initialization. No, scrolling doesn't work, so I'll have to refer to this. I'm using the pixels crate as well because it facilitates some of the stuff. And the rendering part, alright, it should be in here. So in here we might see that I'm initializing the GPU module. I pass the compiled shader in here. Then I initialize the texture for the output that we've seen. Move to top, yeah. And then it's just creating buffers and stuff, but it's like WGPU, and that's why it should work on all three major systems, because WGPU like unionizes is the better word, like unifies them all.
Okay, cool.
Any more questions?
Okay, I can ask some question, but I'm not sure about this applicability of this question. Do you run it on internal GPU, or do you manage to run it on dedicated graphic card?
Yes, so in this case, I have a Mac which has...
It's enough that you have Mac.
Yes, I mentioned I have Mac. Thank you. Next question. No, it works on dedicated GPUs as well. It has even an env option called GPU WGPU power pref, like power preference, which allows you to switch between one or the other. Or even if you have multiple GPUs, pick whichever one you want. I've tested it, on my Mac and both on, I think, Vega, AMD Vega back at home. So it works, I think, everywhere because it uses this unified standard. So
OpenGL.
So actually, what this does is to quickly describe the history. Like we have Windows. On Windows, we have DirectX, which provides graphical facilities. On Apple, you have Metal, which is like its own set of API interfaces. It's not common with DirectX. And on Linux and sort of Windows as well, you have Vulkan. And what this WGPU crate does is that it provides you this unified interface like create buffer, which internally it translates into whatever this particular window, this particular OS needs to actually create a buffer. And because those APIs are like the same for
dedicated and built-in pads, GPUs, so it works everywhere.
Mm-hmm. So it's using some wrapper around OS native graphical.
Yes. So if you were to go into definition to what happens internally, you would eventually find some code that checks if I'm running on Windows, do this, if this is Linux, do that.
All right. Niti, thank you.
Yeah, one more thing regarding the backends you mentioned.
Mm-hmm.
Have you tried to write graphics in some raw bindings for the platform specific API? Instead of platform agnostic web GPU?
I have not. To be fair, I'm a little. For Mac especially, I have not played with its API at all, and there are some bugs that I would like to fix. For instance, in WGPU, or maybe for instance on macOS, one thing that it's problematic for me is that when you bind textures to your shader, you can only bind 16 of them because of internal limits. And this works correctly on Windows and Linux, but on Mac it's got this 16 textures limit, and there is issue to solve this. It requires writing some Apple specific code that I would really like to write, but I'm pretty scared because it touches this Object-C or whatever they have.
Thanks.
So yeah. So now I have only used WGPU, but it's pretty powerful. As far as I went, it has everything I've ever needed. So
okay, cool. Thanks.
Any more questions? So huge shout outs to Patrick. For our YouTube guests, we have lost the camera, but because battery drains somehow, even though it is connected to the power outlet, whatever, we are near the end anyway. We can have some short discussions now, but we are we rented this place till 8:30. And then we will, anybody interested can go for an after party. Most likely this will be Continuacja, I think, because this is the closest place, but let's meet outside Barbara at 8:30. Okay, thank you very much and see you on the next meetup.
Specjalnie wspieramy,